Just to give a brief about indoor air quality, many people feel very tired and uncomfortable even when in air conditioning room. That happens because of the invisible problem, the quality of air that many doesn't aware actually. Like I am from a city called Coimbatore. We are in a tier two and tier three city. Mr. Santosh, who said many people they are implementing a lot of technologies in their premises, but like the tier two, tier three cities, the customers doesn't aware about the importance of the air quality, what is thermal comfort. So we are as a consultant, it is our duty to educate the end clients. Even we are educating the many HVAC contractors also about the indoor air quality. So today I'm just giving a brief about how this AI and the psychrometric engineering can help us manage the invisible IAQ risks. So we spend mostly 90 percentage of the time indoors. So even mostly indoors in the inside the buildings, inside the automobiles. These are all the conditioned environment. We spend most of the areas only in the conditioned environment. The healthy air means it is a comfortable air which gives more productivity. If the poor IAQ, if there is the indoor air quality is very poor, the productivity is reduced, and also like long-term health issue occurs in ASHRAE we call it as sick building syndrome. These and all occurs when the indoor air quality is poor. So ASHRAE defines the IAQ. There are no known contaminants at harmful concentrations as determined by cognizant authorities, with which a substantial majority, 80 percentage or more of the people exposed do not express dissatisfaction. The definition highlight two important aspects: health-based criteria, that is a contaminant limits, and comfort-based criteria, that is a perceived air quality. They actually given a beautiful definition about indoor air quality. So now the main thing, the invisible IAQ risks in the building, that is because of thermal discomfort. Thermal discomfort despite correct temperature. Many people say I'm keeping that set temperature 24 or 25, but even I'm not comfortable inside the conditioned environment. That is because not because of the temperature, maybe because of the humidity or because of the air quality. So the hidden moisture imbalance between the latent load issues, and then undetected CO2 and VOC accumulation. Many people doesn't keep the CO2 or VOC meters inside the conditioned environment. And the microbial growth due to poor psychrometric control. If the system is not designed properly, definitely there will be a microbial growth inside the conditioned room. So in simple terminology, we can say it is a thermal discomfort. These problems are usually detected only after the complaint started. Once the occupants started giving the complaint, then the people go and inspect what is the problem. Is there is any plumbing leakage or what is the problem? Then finally we will identify that the problem with the air conditioning. So the traditional IOQ monitoring, there are key limitations. Even though there is in earlier days there are a lot of technologies are available. Maybe it has some sensor error will be there. There will not be a properly calibrated sensor will not be there. Only there will be a standalone IAQ devices that is not linked to the HVAC controls. Just a namesake, they will be just monitoring the indoor air quality. But what is the use of it? There is no use of just only monitoring the indoor air quality. So nowadays there are a lot of systems and sensors available like CO2 sensor, occupancy or motion sensor, light sensors, airflow meters, VOC sensor, PM sensor, smoke sensors, filter condition and pressure sensor. These are a lot of IAQ monitors are available in the market. So how AI can help this? How AI can synchronize with the sensors? As per our understanding and as per our lot of we are working with a lot of project, we are working with a lot of OEM manufacturers. Recently, we had a discussion with a lot of research scholars. They are more focused towards the indoor air quality, and they are doing a lot of research actually, research on thermal comfort. So AI can recognize a pattern, how the temperature, RH, and CO2 like VOC, PM2.5, PM10, that is maintained in an air conditioning building, and also what kind of filters we use. So this AI recognizes the trends. So at what time the temperature is reduced and what time the temperature is increased, what time the humidity is maintained, and what time the CO2 is goes to peaks and what time the CO2, it recognizes the pattern. So how this pattern helps? So this pattern helps to do the early detection. So based on the user requirement, this AI gives the command to the systems to operate accordingly. For example, for the peak 9 a.m. to 10 a.m., the occupants are coming in. The system AI generates and give command to the AHU or ERV system to pump in the fresh air more. Like this is an example, small example I'm saying. Like for example, if you need more fresh air at the time based on the feedback from the sensor, this AI does a pattern and gives command feedback to the systems to operate. So this gives a lot of energy savings. Basically, it all towards our decarbonization mission. Definitely, this AI with IAQ definitely uh, helps us to achieve the decarbonization mission. Generally, the AI converts all the raw data into useful decisions. And also this AI can we can map the AI system with the psychrometric analysis, and it can rework on the system. It can rework on the cooling load. It can rework on the ventilation rates and dehumidification strategies. This all it can be done easily by AI system, but by manual, it's very really a tough task to do. So as I said earlier, the AI gives a raw values to actionable insights, and it can do a root cause analysis at what time the PM spikes, and based on outdoor infiltration and occupancy correlation, the movement patterns, CO2 patterns, everything can be mapped by AI. AI just not only does a spot measurement, the general regular IAQ monitors only do the spot measurement. If it is combined with AI, it can map the entire facilities data. The future is predictive ventilation. As I said, the AI collects all the data. It collects all the data and it works out its own strategies based on our thermal comfort requirements. So it can predict the occupancy forecast. It can predict the weathers, indoor and outdoor requirements. And also it can predict the HVAC operating mode. Based on a 1 year history, it can predict at summer what temperature is required, winter what temperature is required. And based on the ASHRAE, we can just put in the codes, and based on the ASHRAE standard, it can work the fresher system can work the proper ventilation requirements. On demand ventilation, demand control ventilation can be done automatically by AI. So it's a combination like balancing indoor air quality plus energy efficiency plus comfort. This all can be done by AI. So it's very few examples I can give. If the AI is implemented in HVAC and ventilation system, it can reduce CO2 levels and the infection transmissions in the schools. In hospitals, it can reduce pathogen risks and pressure. The differential pressures can be monitored. In offices, the productivity can be increased and it helps easily for ESG reporting. In residential application, smart air purification can be done and asthma or allergy prevention can be done. In European countries and US, the states, they are giving more importance on residential buildings. In India, I feel there is a more scope in residential building. In India, we are only focusing on commercial buildings and IT and corporates. Residential buildings are least cared in India. I'm really worrying about that. Industrial worker safety and compliance automation. These all can be done AI with IAQ. So comfort, health, and energy efficiency. As I said earlier, it can avoid the over ventilation and unnecessary reheating or cooling. The smart control of outdoor air can be done based on the air quality demand, and it can maintain the comfort with minimum energy penalty. So unnecessarily, we don't want 100% fresh air or more heat can be given to the cooling load. And these kind of systems can help the green building standards and well standards. In general, the future of healthy buildings we are just moving towards the trend digital twins and AI and personalized comfort, infection resilience, and ESG transparency. These are all more combined. The importance should be given to the thermal comfort or IEQ comfort, we can say. In a brief, I can conclude the AI-enabled IAQ contributes to healthier indoor environments, improved occupant productivity, reduced energy consumption, and proactive maintenance strategies, compliance with ventilation standard, and data-driven building management. If we properly do the AI configuration, even it can tell us the when the filter is going to choke. The predictive maintenance will be the alarm will be given by the AI itself. In general, we get alarm only when the filter is choked. But if the AI is enabled, it gives a predictive information to us. The filter is going to choke. You need to replace in 10 days. These are the things the AI can do. But there are some limitations with AI. AI enhances IAQ management, but does not replace the engineering. The psychrometric principles remains the foundation. We need to do the system design properly. Only after designing the system properly, the AI can be implemented. Like I used to say to many people, even nowadays we get the recent engineers send the resume for job application, just copy paste the chat GPT information and put it to us. But if you didn't give proper prompt, you don't get the result properly. So at least you should have a basic knowledge about the psychrometric principle and basic knowledge foundation about the air quality, then you can do wonders with AI. So best results comes from AI plus good design plus skilled professionals. So this is my thought about IAQ, AI with IAQ. Thank you.